And welcome to Comp 621 Web Security. We're going to talk about SQL injection today. Let's see, share screen, and we'll go on that. There you are. I hope you can see that now. And there's our quote for today. All right. SQL injection has, until recently, been the #1 vulnerability in the OWASP top 10. It's dropped a little bit because people are catching on. Of course, it's very easy to for people to do. You don't have to know too much, and companies keep their data in databases. And so, if you can get the database to do what you want, it's a pretty effective attack. So it's easy to do and can have some big impact. All right, we'll start with what you should never, ever do. And unfortunately, from the survey, which I'll talk about later, 40% of the students, no, 50% of the students told me that this is the only way their database instructor taught them to do things. Well, I'm telling you now, don't do that. Yes, this is not at all a good idea. Let's take a look at this. The examples here are in PHP because we're talking about server-side attacks. That's where the database is. And that's where people will be using, we're assuming they're using SQL. In fact, I'm kind of assuming MySQL, although I think almost everything I have here works for almost every flavor of SQL you might have. I did not talk about non-SQL databases. I know some senior projects get real excited about using a non-SQL database, which I think they like because they probably didn't do very well in their database class. Depends on what you want to do. But if you're just keeping data in tables, SQL is the way to go. If you have documents and you want to search it kind of like Google, then non-SQL databases may be what you want. Okay, so here in this example, where we have a variable I call username, just because it seems like a really good input, and it's the input, we'll get it from the user somehow. Assume that you've typed it into a form and it's been sent off to the server. And the server then takes a string, I call it .query, and it's a standard SQL sort of thing, select star, which means select everything from the table students, where name being the column, equals the username. So we're going to get the information from the student table where there has this particular student's name. And then you give this string to SQL, have it run it, have it execute that string, parse it, run it, and do the whole thing. That has a lot of problems. Let's take a look at why. Okay, here, some possible input. This is, again, malicious input. That doesn't look like your name, but you enter some characters, a single quote. And of course, that's because if we back up here, you notice the name is going to be inside quotes. SQL likes data values to be inside quotes. I use single quotes, although SQL accepts double quotes or single quotes as long as they match properly. Also, in SQL, it doesn't matter whether you capitalize the commands or not. I write them like many people do, where the SQL commands are, or SQL syntax is in capital letters, and then the names of tables and columns are in lowercase. And the data is always in single quotes. So we go here, we're going to enter the word anything, junk, a single quote, space, or quote X, quote equals quote X, no end quote. And then you put that, concatenate that in here where you're supposed to put the name, And the query becomes select star from students where name equals junk or x equals x. Note that this first quote comes from the string and the last quote comes from the string. The other quotes I added. So, well, x equals x. Well, that's an obviously true statement. X is always equal to x. Quote something equals quote same thing. It's going to be true. And so this is a true statement. And if you remember your Boolean logic, anything ORed with true is always true. So this is going to say it's going to select that statement. It's going to always select it. In fact, it's going to select everything. This ends up being a SQL statement without the where. It'd just be select star from students. That doesn't work well because many login programs, and I've seen a bunch of students do this, they have that same thing we showed where they have login user ID and password. Now we have two variables in here, same concept. And then this is how in PHP you pass that string to SQL and tell it to run it. And you get a result, which is in this case stored in a variable $result. And then we say, well, did we get anything? Did the number of rows returned greater than 0? Assuming that if the result is 0, if there's no rows returned, then there aren't any lines in the database that include that user ID and that password. So you're checking to see if the user entered the right password. And if you get something other than 0, you say, well, then that data occurs in the database, and so it must be good. Except when they enter this data, it's going to accept lots. You're going to get lots of data. You're going to get the whole table returned. And so, yes, there'll be more than one row or lots of rows. And so this will be true. And so without knowing the password, you can log in to the system. And that, of course, is the whole threat of SQL injection. Now, a little bit more about SQL injection. SQL statements are terminated by a semicolon, just like Java and C++ and other languages. Note that in some systems, particularly I noticed MySQL when running it through PHP, it doesn't want to see a semicolon at the end of the line. That's because MySQL doesn't like it. Other SQL systems, and there are several other SQL systems, don't mind a semicolon. In fact, kind of prefer a semicolon at the end of the line. So MySQL, which is very popular because it works pretty well, and mostly because it's free. Free really speaks to people. It doesn't like semicolons, but it is the line separator. And then the dash dash, two minus signs, is the start of a comment. It's kind of like having slash slash in Java or C++. It's dash dash. After that, everything at the end of the line is a comment will be ignored. So sometimes an attacker will enter data where they wanted to enter name or password or something, and they'll enter some stuff and they'll end it with a semicolon dash dash, which instructs the SQL interpreter to ignore everything after that. So if there's other stuff, just ignore it. For example, here we have another standard SQL. We want to get items where the price is less than what the user inputted and where the owner equals your ID. You don't know your ID. ID might be kept from session variables, so you don't have easy access to it. So that one's going to be hard to crack, but it's okay. We're going to enter the price here. So we enter something that looks like this. 10, so it's going to be the price is less than 10, quote, semicolon, dash, dash. So when this is inserted as input, the quote logically becomes select everything from items where price is less than 10, the end. And the end, of course, is going to be, and owner equals ID, but that doesn't matter because SQL is going to ignore it. It comes after the dash. It thinks of it as a comment. And so we've been able to get through here and enter this data. You can also use the semicolon concept to enter multiple lines of data on a single SQL command. So we have the standard SQL command here where we want to get things at a low price. So we enter the input, instead of entering a number for the price, we enter 10, quote, semicolon, drop table item, where item is the SQL table that was drop table item. And so what's going to happen is SQL is going to execute both statements. It's going to execute the select star from item where price is less than 10, and then it's going to do drop table item. Well, drop table item means delete the whole table. Just make it go away. If you don't want to get real violent and drop it, you can truncate. Truncate's another command in SQL. Truncate simply says, keep the table, but delete all the table. Delete all the data that's inside. So you end up with a table with nothing there. Sometimes that's less obvious. I mean, the drop table, suddenly there's no table and every SQL command gets an error. The database administrator are probably going to notice that pretty quickly. If you truncate it, then the SQL commands simply don't return the proper value, but you don't get any errors. Now, again, MySQL does not allow this. MySQL does not allow multiple commands in every execution. So this type of attack does not work with MySQL, which is good because MySQL, again, is very popular. Also, I think if you saw the XKCD cartoon there I had in the beginning, the little Bobby drop tables, yes, this is where it comes from. All right. And then sometimes you don't know hardly anything about the input. Here we're showing you, for academic reasons, what the SQL command is, and you're putting some information inside. Sometimes you don't know anything, but with running several queries, sometimes you can tell, did the query work or did it not work? Or did you get some sort of error? So here's an example where we don't know what's going on with this query at all. So we try input 5. So we're going to select everything where item where the price is equal to 5. Okay, pretty standard query. Let's assume, just for the sake of argument, that we get one result, just one line. There's only one thing that costs 5, whatever. And then, so we want to, is this system susceptible to SQL injection? So we try 5, quote, or quote 1 equals quote 2, no end quote. Now, quote 1 equals 2, and again, there's going to be a quote inserted before the 5 and a quote inserted after the 2. And so this is going to be or false. Well, you should get the same result because if you remember your Boolean logic, X ORed with false is the result of X. Yeah. So this should return 1. Okay, now you're not really sure whether filtered that out or whether, but you try it again with a different one, with the and instead of the or. And now we've got anything and with false, because 1 equals 2 is always false, it's going to be false. And if this produces no result or an error, then we know, this works, but this doesn't work. Because if this was filtered out by some system, then that would have been filtered out. So now we know, SQL injection is allowable. Okay. Any questions about that so far? Now, having heard your requests for, excuse me, trying to get PowerPoint to behave. Maybe. That doesn't look very good. Let's try. Sorry, I've got like 4 PowerPoint injection things up. Nope, let's try this one. How about this one? How do we make that go away, you ask? Nope, we're Please stand by. We're having SQL issue. Or, oh, right. Okay. Sorry for the delay. Now, I'd like to look at WebGoat. So let's, if I can find, there. Okay, hopefully everybody can see the screen. This is the WebGoat system for SQL injection, A1 SQL injection on the intro. Over here. I guess very few of you actually look at this, so I'll go over some of it. We'll try answering some of the questions and see if you get the same sort of answers I do. Some of these are real simple. The first couple ones aren't SQL injections, they're just tests of SQL, which I'm sorry to learn that many of you have never taken a database class. Well, at least at A&T it's required. I thought everybody would require it. Why would you not require a database class in your undergraduate computer science degree? But I guess some people have snuck through with other degrees or something and don't know that. Hopefully you've had a chance to take a look at some of the online tutorials. They're pretty simple. You don't have to be a database administrator and know all the ins and outs. You have to know the basic, what a select command is and some of the others. And there are several tutorials. W3 Schools covers it. Although, anyway, so here, let's just take a real quick look at this one. Looking at the table, here's our table. And again, SQL is oriented around the concept of a table. The table has rows and columns. Columns have names, and then there's the data and all the values. In this case, we want to find out the what department is Franco in. Okay, so Franco, he's in marketing, but we'll figure that out. Okay, so we'll go down here, and we'll. So if you want to get data back, the key is select. That's the verb you use. Select, and we want to know the department. That's the column name of that we want to know. Select department from, and it's the employees table. I don't know if capitalization is important, so we'll just try it with a capital letter. Because up here, they say employees. We'll make it, if you type it the way they like it, it'll always work. Okay, and then where last underscore name equals, and then of course, quote, Franco, quote. I think that is correct, but let's find out. Oh, hey, we got lucky. Yes, look at that. It worked. Okay, so there's it. And we can go on more Java. 3. There's again, this is just another SQL statement. This is an update statement. We have to update because we want to update existing data, but it's not an SQL injection attack. The next one, number 4, is also it's just an alter. You do an alter. By the way, if you're doing this on WebGoat, you do the alter once to add the phone. You can't do it again because it will complain and says, oh, nope, the column is already there. If you have to go up here and reset the lesson, then it will work in if you feel like you want to run it again, or if you're old like me and you forgot you ran it before. Okay. This one is, again, just SQL. We're going to grant privileges to the user group unauthorized user. There's also the keyword public. You can grant these privileges to public. Okay, 6 is just some examples of SQL, which I've already talked about in the lecture. Let's 7, yeah, actually 8, 9. This one is interesting. This is just filling for this is just select here. So you don't, they give you a couple of ideas. So we want to, again, this is what the query is going to look like. We want it to be John and last name equals something. We're we normally think Smith. So we got the John, the last name equals, well, note again, the quotes. The quotes are what usually makes these things kind of challenging. So we have, so Smith alone will do it. We try this, it ain't gonna fly. No, that doesn't work. Because now, depends on where we're gonna put. It looks like we're putting all this here in the last name. So we're gonna go Smith and put the quote after Smith, but not before it. So that quote here in the input, user input, will match the quote here in the string. And then the or, well, we're going to end up with there's a quote added to the end. So we have to have quotes. So we're going to try this one. Again, we're doing, we want to say 1 equals 1. They're inside quotes. I usually use letters here. I mean, 1 is a letter and it works, but I find it works. But with numbers in SQL, you don't have to put quotes. If you have character strings, you have to put quotes, but you don't have to for letters. So this could be, anyway, so this should work. Well, let's see. Yeah. Obviously, I cheated and looked at this before. But yes, that gets all the information. All right. Now this one was hard for me because I didn't realize the second field is numeric. The first field, you put in some number here, and then this field wants a number. I kept putting in, passwords and secrets and stuff. No, it wants a number. So we'll put in a number, 5, no quotes because numbers don't need quotes. Then we can go or 4 equals 4. I just picked any numbers. Again, 4 equals 4 is true. Anything is true. And so we get that. And yep, we got all the information again. Everybody see that? Questions, statements? Okay, here's another one. And just to make life exciting, if my mouse would behave, let's try a poll on this one. So hopefully you can see the problem. Select star from employees where last name equals quote concatenated with something and auth10, whatever that is, equals quote and auth10. So what values are you going to put in here? Here are some choices in the polls that you should see now. So let's make your estimate of what's the correct answer, or just roll your dice and guess. Oh, a bunch of you are still asleep. Oh, there you go. All right, we only got about 70% of you responding. Oh, there's a couple more. Anybody else? Anybody else has not fallen asleep? Okay, well, let's take a look at what people thought the answer. Oh, okay, that's the end of the poll. Share the results. There it is. People thought, put in Smith as the name and then put in quote X quote, actually Smith or this. The ampersand was just to separate the two values. Maybe I didn't make that clear. Yes. So we could try that. We could put Smith here. And what is that? Quote X quote equals quote X. Oh, nope, I'm sorry. That's supposed to go up here. Or quote X quote equals quote X. And down here, we'll just put that secret code. It's 3SL99A. And let's try it. Uh-oh. Sorry. Do we make a mistake there? No. Okay. Nope. That one doesn't quite work because we're not putting a quote around Smith. Now, about 30% of you thought it would be Smith, and so we can try that one. Actually, what works, at least worked for me, is I left Smith alone, and then down here, I ended that with a quote to end that field, added quote X, oops, that's not a quote X quote equals quote X. Again, if we look at this, we see that, let's put this up here. Can everybody see the web goat?
Yeah, we can see it.
Okay, good. I never show what you're seeing. All right, so let's try this one. Hey, yes, all right. 30% of you got it. That works. And again, that works well because we let the name go. Don't try to do it. We put the SQL injection at the end. It tends to work best at the end. Although, of course, we don't know where the end is if you don't see the quote or the query, but put it here. So we ended that. Any questions about that? Everybody see why that works? Since only 30% of you got it right. All right. We'll do more polls later. And that, well, okay, that one, let's see. We were up here doing SQL stuff. What was this one? Oh, this one's pretty straightforward. Or actually, no, it's not. This one wants you to do SQL tree chaining, which means put two commands in the SQL statement at the same line, which of course doesn't work with that's number 12. So we put Smith here, and then down here, just a second. I'm going to put a great big long statement. And let's just take a look at this real quickly. It's got the authentication. There's this authentication quote, semicolon, end of line. The next line says update. Well, where's our line? Okay, update employee. We're not seeing anything, are we? Employees set salary equal to, oh, I'm going to up that to another number, 100,000, because I've done this before and it might just tell me I'm not, number's not big enough. What name is Smith without the quote in the end. And let's try that. And hey, yes, it worked. Previously, I had accidentally sent everybody's salary up to 100,000, which probably nobody complained. In order to make yours bigger, you had to make it a little bit bigger. So that works. Okay, well, that's examples of SQL injection. Any questions about that? I find WebGoat be a lot of help to practice these things. Okay, so let's go back to SQL injection. If I can. No. PowerPoint jumps to full screen whenever you show this stuff, and then you can't see Zoom. Okay, here we go. And we will look at the slides. All right, hopefully you're seeing the slides. We've seen that slide, blind one. Okay, and okay. Well, what to do about this problem? Since this is a very serious attack on web systems, there are several things here. And We can use prepared statements, stored procedures, whitelist value, escaping all the input, and least privilege. Let's take a look at these individually. Okay, here is what I think the easiest answer to the whole problem: prepared SQL statements. And alas, it doesn't appear that too many people were taught this. This is what you should know. This is how you should always do an SQL statement in a program. Now, my example here is written in PHP, not one of my favorite languages, but again, it depends on what your backend system is. This again is a backend attack, server attack. It's not dealing with JavaScript or the browser, it's dealing with the server. And so this is in PHP. And let's just go over this real quickly. Oh, by the way, in my example here, I took out all the error checking. I actually kind of copied this from a program that I had written, and there's error checking almost every step along the way. You know, for each statement that you have, you check to see, will that work? The first statement is create an SQL object opening up your database. And of course, there's an error if the database is, but it's object oriented, so it's got new. And so now SQL Obj is my SQL object of the type MySQL. And of course, I'm using MySQL because it's free. Okay, so I make a string. This is how do it with prepared statements. You know, select star from students where name equals, but instead of concatenating the string together, I put a question mark. Each parameter is indicated by a question mark. And so when the next step, we're going to do the prepare, we're going to stick variables where the question marks go. And you can do multiple ones. I only have one here. I probably should have shown an example with multiple ones. But yes, so, okay, after you make the string, you prepare the statement. Now, that means SQL is going to parse the string, see that all the words are correct and it looks good, and find the question marks. And then optimize the command. SQL optimization, by the way, is a big topic. You don't just run it the way it looks. You got to make sure you run it efficiently. Makes a big difference. So now we have this variable which I call SQL statement, which is the parsed version of this select statement here. Then we do the bind param. Bind param takes two parameters. Actually, it can take any number of parameters you want, but there's the first parameter tells you the data type that you're going to replace. I'm going to use a S for string. There are several different types. The only ones I know are S for string and I for integer. I'm sure there are more, but I've never used them. So S, and then the variable. So now it's going to logically say, whenever you come across that first question mark, that's going to represent a string whose value is stored in username or will be stored in username. And then you can execute that statement. And then you can get the results from the execution of that statement. And now we've got results, we can go on. The nice thing about this is it does not in any way stick this data into the SQL string before it's parsed. You parse it first, and then it uses the values that you give it. No matter what you put in the string, it's going to consider that as data. And if you have multiple, let's say we had name and password or something. Well, we go quote SS for two strings, and then you put username, comma, dollar, password. If you have integers, it'd be like SI with username, comma, ID number, or whatever it is. So anyway, look it up. As my father used to say, look it up, you'll remember it better if you need to use it. But this is how you ought to execute SQL. Do not just concatenate string. This works so much better. There's many advantages. One is no matter what you put in as data, no matter what attack sort of information you put in, it's going to be just considered data. So if you put in something like, like Fred, or like this, Fred, quote, or then it's simply going to say the data that you're looking for is FRED, quote, space OR, space, quote, X, so forth. It's just going to be looking for those letters. That's the data. It doesn't in any way merge that in with the SQL statement. It just considers it data, which eliminates all the problems of SQL injection. Another thing, if you happen to be doing this statement more than one time, then backing up, you can do, obviously open the database, do the select, do the prepare, do the bind, and then you can change the value in the username variable and execute it again, and change the variable, change the value and execute it. So if you're going to do this for many times, this is the way to do it. You don't parse it multiple times. You need to do the prepare or the bind. You just do all these once. And then all you have to do is go like $username equals something, and then execute it, and then say $username equals something else and execute it. So it's much more efficient and runs a lot faster. Besides, if you remember with computers, if you can get it to work once, it's likely that it may work better it may work again the next time. Doing something new every time may or may not work. Okay. Another safe way to execute SQL statements instead of concatenating together is use SQL Stored Procedures. In a stored procedure, you put the series of statements that you want executed into the SQL database. There's a command for that. Look it up, you'll know all about it. But you store these and then you can execute that stored procedure. Stored procedures can have parameters, very much like calling a method. You pass it parameters and they are passed into the stored procedure and executed there. So again, the values that are input are treated only as data. They're not considered as part of an SQL statement. So it avoids the SQL injection. Something to note, that you have to have execute privilege in the database. SQL databases have all sorts of privileges that you can give to users or not. They can have read data. One of them is execute. You're allowed to execute procedures. And so you want to make sure that the web server is running with the execute privilege on this database. Some people who aren't real good at database management, but they have to do that anyway, I'll say, I'll just give it full privileges. I'll make it a root user database administrator, and therefore it can do anything, and that makes it work. Yes, it's that solution that makes it work. Unfortunately, that solution that makes it work also makes it very vulnerable, because now your web system has full privileges and can do anything to your database. All right. Another thing you can do, like we've seen before, is try to sanitize your input. There's a couple ways to do that. One way is to change the special characters to the ampersand number value, or I think this changes it to like ampersand LT semicolon, and it takes out the characters that are going to cause you problems. So it's called real escape string. In this case, it's a PHP command. So we call it on the SQL. Okay, it's a PHP command for SQL, but that goes out there and it replaces the characters, and that will avoid the most particular takes out the quotes, and it avoids quotes breaking out of a quote string and becoming commands. So that there, from careful reading of the web, some clever people have been able to get through this, but that is one way to do it. Another way to do it is that if you have input, then just set the variable that you want to the value you want. In other words, say you have a database and you're going to ask the user, do you want it to be greater than, less than, equal to, or something like that. And it might have like a pull down menu. Remember, of course, that some clever person may be using Zap and have changed the values from the pull down menu as sent over. So you have to check it on the server side also. What they do is, we take that value and we just put it in a case statement or something, and then say, if it's this, we want it to be that. You can even use numbers here, but this is what we want. In other words, you don't take the user data, you translate the user data into what you want. So these are the values that will end up in the SQL statements, not these values. But assuming they gave a correct value, you'll translate it over here. And then at the end, you've got this default. If they gave you something that's none of the above, throw an exception, which would be, work really well if you had a pull down menu and you said, these are the choices. Pick, one, 2, or 3, or, return to values 1, 2, or 3, but somebody had messed it over for you and they gave you something else, you'd catch it here. Another way to do it, this is a program I wrote in PHP. I only wanted letters, numbers, and spaces in a particular field. I was kind of picky. I didn't want no quotes, nothing else. If it wasn't a letter, number, or space, then it was wrong. So I wrote the function. It just goes in here, passes it a parameter $dangerous. I split it, creates it into an array, and then being a string, it's now an array of characters. And then for all the characters, I get the number value because it was easier to compare to, easier to do. I say, okay, is it an uppercase letter? Which, if you know your decimal ASCII values, are 65 is an A and 90 is a Z. I'm sure you remembered that. And then number, lowercase numbers. And then the last thing is, is it a space? If it's not any of those, you got an error, return false. Otherwise, you go through the whole loop. If you haven't returned false, then you return true. Pretty simple. But that's, again, if you have specific input types that you want to check for, you can do it yourself. And another way that I've been reading about is to encode it. For instance, Base64 encoding. Take the data that the user enters. When you put the data into your database, Base64 encode it before you put it in there. So if you got the user's name, Base64 encode it, and store the Base64 encoding into the database. And then when you get the input from the user, Base64 encode your input, and then see if the string that the Base64 encoded string that they entered matches the Base64 string in the database. Since Base64 has a very limited alphabet, it's got upper and lowercase letters, numbers, and I think pluses and slashes. But that's it, nothing nasty. So no matter what they entered, it's going to be Base64 encoded and goes into nice, safe characters. Okay. Now, one of the things you also want to do about protecting your system from SQL attack is not tell the user all the details about your system. Try to keep it secret so people don't know, what's going on. Now, when you're developing your application, when you're building this thing, you want to print all the errors you can get so you know what's going on. And of course, remember old Dr. Williams's pet peeves is students who never check error returns. They always assume every function works perfectly. And so errors occur over and over again and they never catch them. Even worse, by the way, since I'm on my stump now, people who have exceptions and then in the catchphrase, the exception, they do nothing. So an error occurs and they ignore it. And so I've seen programs by graduate students, no less, that are getting errors every time through the loop. And, it throws exception, catch it, do nothing. It keeps going. They don't know it doesn't work. Anyway, enough of that. So, yes, when you're debugging it, check the errors every time. Make sure you set the parameters of your system to display all the data you can. Makes it much easier to debug. So when something doesn't work, you go, oh, that's what it was doing. Now you can figure it out. But when you move over to production, turn off all the errors. Don't give the users all the information they have to know. Same thing occurs, by the way, with web servers. When you're testing your web server, have it display all the errors. You can see some systems display a full page of information about what went wrong, what directory the file was in, what you did, and this, and that. But you don't want that in a production system. You just tell them there's been an error. Don't tell them anything. And it is useful to write things to the log, the system log or the Yes, so if there's things are going wrong, write to the log, because then the programmer, the database administrator, somebody on a regular basis can look at the log and see if everything's been working all right, or if there's been errors. If you start seeing errors in the log, you go, got to go out and fix something. When you write things in the log, never ever write passwords or anything private. It shouldn't be publicly available because you don't know who's going to be looking at your logs. It's okay. Now, a general policy for security, not just SQL injection, not just web security, but for all security, is the concept of least privilege. Don't give people more ability than they need. That way, it can't be abused. So only give them the privileges that they need. Now, there's an account that your web server runs under, whatever it is in your system. But your web server will be running under some user. So it should not be root. That's not a good choice. Root has, and it has lots of privileges. A Linux system, root is the big thing, or an admin in Windows. Just, run it under another user. Just create a user that is the administrator and give it only the privileges that it needs. Now, it may need privileges beyond what Joe average user does, but don't give it more than it needs. And again, for every application, if you're going to need to read, if this application only reads this database, only give it read access. If it needs, don't give it write, don't give it manage, don't give it others, just give it read access, or whatever it needs. Also, there's the concept of a view. SQL has the idea of a view for database. So instead of seeing the tables that exist, you can say, here is a view or a subset of the tables. In other words, you can provide a select statement to SQL and say, when somebody wants to look at this table, only see the rows that meet this select statement. And so it's just not possible for a user who's looking at the view to see the other data. And that way, it certainly reduces any problems, any exposure, any errors that might occur. Only show them what they need to see. And there's also a file option in SQL. File means allows you to save a file on the server. This is somewhat independent of your ability to read a file with JavaScript. But once you send the file over to the side, you can say, store this file on the database, or store this, not so much in the database, store this file someplace on the server. Well, if you don't disable that, one of the key tricks is to put the file on top of, another file. Put it, put it on top of your passwords file. Just change that. So it's a good idea. Unless you really need to do that, don't do it. And then another concept for when you install your database, your SQL system, disable TCP network access unless you need it. Now, a lot of database systems will operate in a distributed system, but you can have one computer has your database and other computers send it request over the web. It's just like a HTTP request. In fact, it travels over HTTP, and you send a request that says, this is what I want, and it sends back the result. And that allows you to have a centralized database and many different machines accessing that database. There's a lot of value. But if you're not doing that, disable it. Because if it's alive and you say you're really only using it on the one, you have the database on the same machine where your web server is, then you don't need to access it through TCP. Access it through sockets or named pipes. It's another way to get the information. Besides being more efficient, others cannot get to the database except through your program. Now, if you are going to do the access across the network, make it secure. HTTPS, use transport layer services. By the way, there is a pre-recorded lecture out on the web now for TLS, transport layer services. That's the last of the lectures on encryption. We had the one on public key, one on private key. and now TLS. It's really short. It's under 9 minutes. The reason it's taken so long to put out there, I kept trying to find more stuff to put out, and I just, make it short. Okay. Now, so another thing again, make your database so it only binds to local hosts. So you can only access in the local host. And use the firewalls. If you have firewalls, make sure if you're going to access it, keep that stuff from being on the firewall. Another big advantage is to keep it someplace else in an isolated area, what they call a DMZ Demilitarized Zone, someplace that's inaccessible from the outside, so that others cannot get to it. Only your application can get there. Another trick too is to have different databases for different purposes. Instead of having everything in one big happy database, have different databases. You may have one database for your catalog, for all the information about what you want to show the users, and another one about orders. The nice thing there is that you can provide read access to the catalog database so they can only read that, but then they can update the orders catalog because you have to update that in order to make an order. And that protects the catalog. So, worst case, they might screw up your orders, but they won't mess up your catalog. And also, there's I might mention the program Phpmyadmin, which really has almost nothing to do with PHP. It's a MySQL tool to manage your database. I'm not sure how to easily manage it without it. Yes, but you always, I always install Phpmyadmin on any system I'm working on with the database, so I can go out there and look at my tables and create new tables, new databases, and all those things you want to do. It's a graphical user interface to do all these sort of things. It works really well. But don't let everybody else use it. Okay. SQL databases come with passwords. Make a good, strong, unique password, long, random characters, particularly since generally humans don't have to enter it too often. So make it weird. Yes, I think I just said this. Database should only be used by application. And then don't put the database of passwords and other critical information in your application program, not in the PHP. What you should really do is put them into a file that you include into these, and then keep that file someplace else. Make sure it is not accessible from the web. What they say, the web root, when you have a web server, there's a root, what would be just slash on the web server. But that is just a directory in your system. If you put something in another directory that isn't accessed by the web, then you can't see it from the web browsers, or the web server cannot access it. So put your credentials in another file, another directory. And of course, using your system authorities, don't let other people see it. Just only allow it to be read by those who are supposed to read it. And also, don't go out and check it out to GitHub or other places where people will see it. Okay. All right. One more thing about this is not SQL injection. This is command injection. Part of the general concept of putting commands in, or it's not SQL commands, but in this case, operating system commands in places where you don't want them. So this is where command injection, when somebody inputs a command, think of like DOS commands or command mode commands, or if you're on a Mac system or Linux, we have a terminal, we have commands like that. We can execute those. Now, in most programming languages, there's an ability to execute a command, a system command. For instance, something I've used before is, okay, at some point, you need the user to edit a file. Well, you can go to all the trouble of writing your own editor, which is a pain, or just pop open Notepad or Terminal or something and have them edit it that way. And then when they're done, exit the editor, your program knows, oh, Notepad is done. and you go back, you grab the file, it's been updated. And that way they can use a well-known editor and you don't have to write it. Okay. But here's the problem. Let's say they're supposed to enter their file name. They're going to pick the file they want to edit. And they add this ampersand evil command, where evil command is some DOS or command mode command that you don't really want to execute. The ampersand in the Unix DOS world says execute this command and that command at the same time. So the program, when you do this, the program is going to go, okay, system, it's going to call system, notepad, concatenated with the file name, which is what you expected, but and equal. And now it's going to open up notepad to look at my file.txt and execute the evil command at the same time. So that's something you want to avoid. Same tools to avoid this as you would use to avoid SQL injection. And now a opinion from your old instructor. You start to look at the problems we've seen here: SQL injection, cross-site scripting, cross-site request forgery, and a bunch of others we haven't covered yet. Many of them have the problem, and that somewhere along the way, the system is going to interpret the data as if it was a command, as if it was a script or something. Cross-site scripting, we're putting in script that somehow we trick the system to execute. SQL injection, again, we're entering data that somehow it makes the system think it's part of a SQL command and execute it. Same thing with command injection, all these. And of course, you have languages like PHP, which mixes the text that we display on the screen, HTML commands and PH code are all interweaved. And sometimes they get unwoven and not executed the way you thought they were going to be. I might note, it doesn't have to be that way. You don't really, shouldn't do it. Think about Microsoft Word or other text editors. Typically, you don't see any of the markup. There's Microsoft Word, you don't see bold. There isn't a bracket bold. Now, I admit there's a keystroke. If you go Control B, it makes things bold, but you don't see it in the text. You just see the text. The formatting is hidden from it. So I'm not saying we should use Microsoft Word for all this, but something like that. Here's a way, here's something for you to help the universe and the world by coming up with something better. Now you have to remember Tim Berners-Lee invented HTML before they had JavaScript. You didn't expect to run anything. You're just going to display the text. Yeah, this is before anybody displayed text and had links. Either, yeah, we'll just do this. This is fine. And it works really well if that's all you're going to do. But by now, 30 years later, it is morphed into a distributed programming system. And we have all these problems, these security problems that are a result of somehow convincing the system to interpret the text as instructions. So think about how you might create a system that doesn't do that. Let me know if you got any ideas. We'll publish. All right. A couple of announcements, and don't go away too fast. I've got other things after this. Yes, there is an assignment out there, the Aggie Weather app. I love the weather app. It doesn't tell you what the weather is. It lets you set what you want the weather to be. Isn't that what a weather app really ought to do? Yes, as Mark Twain said, everybody talks about the weather, but nobody does anything about it. Anyway, it was going to be due on Wednesday, but I moved it back to Monday. Remember, by the way, Thursday is the mental health take the day off day. Thursday is an A&T holiday. No classes on Thursday this week. No assignments are due. If anybody has an assignment or a class due on Thursday, let me know. We'll squeal on them. Okay. So in order to do the assignment, there are 3 things you have to do. You have to log in. I gave you what your user number is, but I didn't tell you the password. I figure you can figure that out. Let's do a little SQL injection and get past that password problem. And then it's going to ask you to print out a bunch of values, and it's going to also ask you to enter some new temperatures. Think about the temperatures. There's a limit. You can't enter any temperature over 40, which I find kind of chilly and nasty. So we want to be more positive and do something warmer. By the way, we're assuming these are degrees Fahrenheit. Degrees over 40 Celsius are kind of nasty in their own sense. Okay, so and you may use the debugger or Zap to fix that. And then when you get it, I will know if you've entered some new temperatures because it'll be in the database. You'll have your ID number. Well, it's not your ID number, it's your login number. And again, you'll be able to see other people's login numbers and temperatures. I'm hoping that it's not too easy to go backwards, that even if you find somebody's number here, that you can't easily tell what the last 3 digits of their ID are. At least not easily. Okay, so I'll know if you got first part and the second part done. The third part, just get some data and give me a couple of those temperatures that aren't yours and put them on Blackboard. Just copy and paste them into a text file or into Blackboard and show me what you got. So I know that you did it. That's fine. Okay. What's coming up? Well, first of all, next week, which was supposed to be the topic this week, is XML externality, XXE attacks. Sounds like some porno something. Anyway, the XXE attacks are going to be the topic for next week. But please read chapters 12 and 24 of the textbooks. At least those of you who have textbooks. Those of you who don't have textbooks, well, get out to Wikipedia, Google, and start reading about XXE attacks. And then 2 weeks from today, on the 23rd, there'll be another exam. I'm still contemplating what should be the format of that exam. I wasn't particularly pleased with how we did it last. Well, it might have been really great if it worked, but because of all the troubles we had, I'm going to try something that's less error prone. So if you have thoughts, comments, ideas, let me know. Speak up now or send me an email or something. But we're going to be examined 2 weeks. Okay. And I want to have office hours or student hours. I'm sorry, a couple of years ago, they changed office hours to student hours. So we want to have student hours, to be politically correct, or student hours. It's going to be, basically it's an optional Zoom meeting and we're going to have it. So let's figure out what's a good time to have this on. So I have a poll. Please select your preferred time to have student hours. You can pick all the times. In fact, I would prefer you click all the ones that you would be happy to attend. Yeah, so. Okay, a couple more people waiting for 3 more people to put in their opinions. Remember, you don't put in your opinions, we just won't know how it's going to work. All right, there's somebody who's fallen asleep. So sorry, fella, we're just going to give you 2, 1, 0. That's been a minute, you lose. Snooze, you lose. All right, here are the answers. Well, Fridays at noon or Fridays at 1 are very popular. So let's do it then. I would prefer Fridays at noon myself. Actually, I prefer Friday morning, but there's a computer science faculty meeting on Friday mornings. So Fridays at noon. So this Friday, and from Fridays henceforth until I get tired of this or it doesn't work, we decide to do something different. Let's have an optional Zoom meeting, Fridays at noon. Is that a problem for anybody? Does somebody else have a class Friday at noon and they couldn't do it? Well, at least we can get 70% of the people there. Okay. And again, you don't have to show. But if you have questions, you can show up Fridays at noon and we'll talk about it. Okay. Any other questions about it? I have just a little bit more I wanted to do here. Let's all right. Close that, go to here and stand by. Can you see the online teaching survey results?
Yeah.
Was that a yes or no?
Yes, we can
Yes.
see.
Oh, cool. Okay, thank you. Sorry, just sometimes I don't know what you see. All right, there were several questions. I'd like to go over them now, and I really would appreciate your input. Okay, so should I show the instructor running demonstration programs? Which you might have noticed, I did WebGoat today. I tried to do that. Yes, and generally, yes. If there was an even split between agrees and strongly agrees, which I assume that means you want to see that. I'll try to do that. Sometimes it takes a while to come up with a good demonstration because of all, if I was really good at this, it'd be faster. It took me almost a day to make that AccuWeather app, which it should have been easier, but it wasn't. If I was better, it would have been easier. Okay, another question. Should we do some poll questions? I had a poll question today or two. We'll try to add more. And the average response was agree. There were some people were neutral, some people were strongly agree. That was response. Okay, another question. Should there be more assignments? Well, that was not treated very popular. That actually had a wide range. There was at least somebody looking for almost every answer. Some people strongly agreed and some people strongly disagreed. There were several strong disagrees and disagrees. So yeah, so that was some answers. The average, I put numbers on them and I got a 2.87 average, where 1 is strongly disagree, 5 is strongly agree, 3 is neutral. So it's a little below neutral. But on the other hand, on the response to the question, what can the instructor do to maximize your learning? Multiple students said more in-class assignments. So I guess mini assignments. We're going to have not homework type assignments, but we'll try to do more. I guess that's more demonstration type stuff. Well, okay, we're going to shoot for that. Another response here about your undergraduate database class. Only taught dynamic statements, and that was it. Half of you said that. Might I ask, for those of you who got your undergraduate degree at A&T, who was your database instructor? Because it's usually
Mine was
Kim.
Dr. Kim.
Dr. Kim. Dr. Kim often teaches that class. Sometimes, Dr. Hinton. Those are the two, maybe Professor Puro. Anyway, so Kim. Okay. Well, I've already sent an email to Dr. Kim saying, "Yo, can't we fix this?" And hopefully we will. Okay. And then no database class, 38%. I'm sorry that there was lots of database stuff and I didn't really talk about databases. I did try to direct you to database tutorials online. I thought everybody would have had a database class. But again, some of you don't have a background in computer science. And we're going to talk about that. I'm catching on to that concept. When I originally started teaching this, I thought everybody had an undergraduate degree in computer science. That's kind of how I oriented the class. I now realize that that is not a true statement. And so I'll try to make this more friendly for students whose backgrounds are different. So I'm working on it. Stay tuned. All right. That should end this. Let's stop sharing. I'm back. And some people had Hinton. I'm looking at the chat. Hinton and okay, well, I'll tell them both. So there, that'll show them a thing or two. Okay. Anyway, any questions, statements? Anybody want to add anything to the survey? Now, the survey was due today at noon. Less than half the students took the survey. It's still out there. You can still put your 2 cents worth in. So let me know what you think. And taking a look at it, I'm going to try to implement these things. I probably should have put a question in there, what the best format for an exam is. Anybody have concepts on online exam formats, what you'd like to see? I hear nothing.
I like the current format with
Oh,
the documents.
the long all day exam.
I just like it because I have time and throughout my day so I can like start on it and work on it.
I think I hear another student saying, don't do that again.
No, I say I like that.
Oh, okay. Well, I could do it because some people told me that, well, first of all, they couldn't do this at 2. Some of the people who are not attending the class right now don't do that because they work at 2 o'clock or whatever, and they watch the recording. Yeah, that's why I made it long. Okay, I'm going to try to make it an all-day exam. I like exams in this class or in any class that are do-it things. I think you might have seen the Sophocles quote a couple weeks ago, where you don't know it unless you do it. That's how you learn. You learn by doing. And you can show me you know it by doing it. So we'll try to have something like that. And I'll try to make it simpler. I'll try to give you better clues as to what will be there. And again, try with lots of time ahead of time to give you a sample exam. So you can look at that, tell me if that, if it offends you, if in some way it requires you to know things that you don't know outside the material of this class. If you don't know the material in this class, well, that's just too bad. Talk to me about it. But my real concern at this moment is that it requires you to know some background computer science concepts that you don't know. Sometimes, hey, Graybeard, this program has been programming for 50 years. And what do you mean you don't know that? Well, I've known that for decades. So we'll try to get that to work. All right. If that's it, well, a little short. We're supposed to run for an hour and a half. There is a pre-recorded web video out there on transport layer security. Take a look at that. It's less than 9 minutes. It's pretty easy. And I'll be putting another one out there too. And please read the book. If you think you're going to learn everything just by listening to me, you're sadly mistaken. Okay, that's enough for today. See you next week. Oh, see you Friday if you want. If you want, Friday at noon. I'll send out an announcement about that. Friday at noon. Otherwise, adios.
Hey, will you be like recording those sessions also?
Yes, I think people want those
Okay.
recorded. I will do that. I'm going to stop recording this one though. I can find the right button.